Welcome on this e-learning platform of Apex Institute of Physics. Here is the general information about the instructor and the course. Electrostatics is the chapter we are dealing with. Application of electrostatic force, that's a Coulombic force we will deal in this video. So let's proceed. In the stability of charge there is a case 2. This kind of questions also very common. It says there are 2 point charges each of plus q value, so they are identical and they are fixed. So let's say there's a q1, there's first charge q and there's another charge q2, q. Both are fixed at a separation r, so the distance is r. And then there is a third charge plus q, so capital Q is at the center initially, and then this plus q charge is slightly separated or displaced in, let's say, plus direction, so that's a slightly displaced along the line, and then it is set free. We need to prove that this is going to performing SHM, and we need to find the time period. So when this plus q charge goes to this new location, that's x distance apart, it will experience a force because of first charge. So this is F1. It will be repulsive away from the charge first, and then because of the charge 2, this charge will also repel this charge, so F2 will be acting in opposite direction. And here we will find the net force. Net force will be equal to F1 minus F2 using the vector rules. Now if we use the Coulombic force expressions, it's going to be K Q Q divided by, for F1 we will find it's going to be R by 2 plus x whole square minus kqq upon r by 2 minus x whole square. So this will be the net force acting. Here x is said to be very small as compared to the other dimension r. If we can simplify this form expression, so this is going to be kqq, and in the bracket we will find this differences, so this will become r by 2 minus x whole square minus r by 2 plus x whole square, and in the denominator we will have product of these numbers, that means r by 2 plus x square into r by 2 minus x whole square. Now if we simplify this big expression, we will find this k, q and the small q will come out, remain as a common. This is a square minus b square, so you apply formula a square minus b square, so we need to write a plus b and a minus b. If we write a plus b, we will find r by 2 plus r by 2 will lead to simply r. And then a minus b, when we go for a minus b, we will get it's going to be minus 2x. So this minus 2x will be there, and in denominator if we go, this denominator will become a plus b into a minus b, that's a by a square minus b square, and you will find there is a whole square, so that whole square will remain there. Further simplification will lead to this net force F is equal to minus 2 K capital Q small q R x divided by this denominator. In this denominator we can say x is very small, so we can ignore x, so this becomes r raised to power 4 divided by 2 raised to power 4, that is 60. Now if we simplify this, so this will become minus 32 k q q divided by r cube into x. Looking at this force, we can claim this is going to be SHM, and we can find this is going to be the k value, let's call it k dash, so time period will become 2 pi under root m by k dash. That's the answer.